In this video, I want to have a look at something called completing the square. So we've looked before at factorising quadratic equations in order to solve them and find their roots and be able to sketch parabolas. But factorising only works for certain quadratic expressions. So a lot of the time we can't factorise expressions. The method of completing the square that we're going to have a look at in this video will work all the time. No matter what quadratic equation you have, you can always complete the square. So completing the square is based around perfect squares. So the idea is whatever expression we're given, we're going to manipulate it until it represents a perfect square, and then we're going to factorise it. Okay, so we've got two examples here, and we're going to go through and complete the square for each of these quadratics. So I've just got our perfect squares written over here to help us. So what we need, if it's going to be a perfect square, is we've got our a squared plus 2ab plus b squared. So whatever this term is, and this term is, we're going to multiply those together and then double our answer to get our middle term. So here you can see that our x is already in this middle term. So to figure out what b has to be, we're going to halve that coefficient of x and then square it, and that'll give us this whole term on the end. So at the moment, this 5 isn't what we want, so we're going to move that out of the way. So we're going to have x squared plus 8x, and then just over here somewhere, we're going to write our plus 5. So we're going to figure out what number we're going to put in here to make these first three terms into a perfect square. So like I said, the coefficient of x, we're going to halve that. So half of 8 is 4, so we're going to add on 4 squared. But we can't just add 4 squared into an equation because that completely changes what that equation is. So to balance that out, we're going to subtract 4 squared from the end. So we've added 4 squared in here to make these first three terms a perfect square. And then to balance that, we've subtracted 4 squared off the end. So what that means is that these first three terms factorise into x plus 4 all squared. And then we can have our plus 5 minus 4 squared. So 5 minus 16 would give us minus 11. So we've still got our y there. So we've just rewritten this quadratic in this form. So we've got x plus 4 all squared minus 11. All right, our second example, we're going to go through and do something really similar. So we'll start off, we've got our x squared minus 4x, and then we'll just write our plus 7 off to the side. So we need to figure out what number we're going to put in here to make this first bit a perfect square. So we're going to halve this term in front of the x. So half of 4 is 2. So we're going to add in 2 squared. And then to balance that out, we're going to have to subtract 2 squared from the end. So these first three terms then, they're going to factorise. And because of that negative, we're going to have x minus 2 instead of a plus like we did over here. Because it's a negative there, it's a negative here as well. So x minus 2 squared. And then we've got plus 7 minus 2 squared. So 7 minus 4 would give us plus 3. All right, so we've completed the square on both of those things. Now, how does that help us is the next question. If we have an equation just y equals x squared, you guys know that that's a parabola that has its vertex at the origin. So something like that. Now this term on the end, this minus 11 term, or this plus 3 term, that shifts our whole parabola up or down the axis. So this one, that minus 11, would shift it down 11 units, and that plus 3 would shift it up 3 units. Now the term inside the bracket with that x, that shifts our parabola either left or right. So this plus 4 shifts it to the left 4 units, and the minus 2 would shift it to the right 2 units. So what that means is once we've got it in this form, it's really quite easy to read off the coordinates of the vertex because it's shifted it. So this one here would have a vertex with an x coordinate of minus 4 because it's been shifted 4 units to the left, and a y coordinate of minus 11. So we can read straight off the coordinates of our vertex. This one would have coordinates of 2 and minus 3. So just to write that a little bit more generally, if we've got an equation, a quadratic equation, in the form y equals x minus h squared plus k, then the vertex of that quadratic function is at hk. So we can use this method of completing the square to help us graph or sketch our quadratic function. So in this one, it asks us to complete the square, sketch the quadratic function, showing all key points. So those key points are the coordinates of the vertex and the x and the y intercepts. So let's start off by completing the square. So we're going to have y equals x squared plus 10x. And then over here, we'll have our plus 19. So to complete the square, we're going to halve that 10, which would give us 5. So we'll add 5 squared. And then to compensate for that, we'll minus 5 squared. So those first 3 terms then will factorise to x plus 5 all squared, and 19 minus 25 will give us minus 6. So from there, straight off, we can read off our coordinates of our vertex as minus 5 minus 6. Then we also need to find our intercepts. So we know if we're trying to find our x-intercepts, we're going to set y is equal to 0. So we're going to have 0 is equal to x plus 5 all squared minus 6. If we added 6 to both sides, and I'm just going to flip this around, we'd have x plus 5 all squared is equal to 6. Then we're going to take the square root, so we'll have x plus 5 is equal to plus or minus, and that bit's important, plus or minus the square root of 6. So x is going to be equal to minus 5 plus or minus the square root of 6. So we do have 2 roots of our equation, but they're not nice whole integers. But that's okay, we can still graph them. All right, then we need to find our y-intercept. And to do that, we're going to set x is equal to 0. Now you can do that in either spot. You can do that in this factorised version, or you can do it in this, the original equation as well. Either one's going to work. I'm going to put it back in this original one, because when we do that, this first term just becomes 0, 10 times 0 is just 0, and we're just left with y equals 19. All right, so then we're going to sketch it, and it is hard for me to do on this tablet, but you're going to get the idea, and you should be using a ruler in your grid books to do this. Okay, so there's our axes. We've got a y-intercept of 19, so we're going to put that way up here somewhere. We've got a vertex of minus 5, minus 6, so that would be about here somewhere. Now these numbers are a little bit harder to see where our x-intercepts are because they're not nice whole numbers. We're going to leave them written like this because this is exactly what our roots are. But to help us graph it, we can approximate them. So minus 5 plus root 6 would give us about minus 2.6. And minus 5 minus root 6 is approximately minus 7.4. So that just gives us some idea of whereabouts to put them. So we'll put our first minus 2.6 at about here. So that's going to be minus 5 plus root 6. And then the other one just about here. So minus 5 minus root 6. All right, and then we've got to join the dots to draw our parabola in. Now again, this is really difficult for me to do on here, but we'll just do the best we can. So you've got to make sure, you should be making sure that goes through there. And you guys are doing all of this in pencil as well, which makes it a lot easier. If you make a mistake, you can rub it out and keep going. All right, so that's a quick look at a few examples of how we can complete the square and how it can help us to sketch our quadratic.